All right, Jack. So let's go through this worksheet here, and let's just go through these problems. Which ordered pair is not a solution of 8 minus xy is less than or equal to 8? Now, probably the easiest thing to do is to simply plug in the numbers. So let's start with that. So 2 for x and negative 4 for y. So this isn't working. I had to close this. Open it again. Okay, there we're going. All right, so A is 2 comma negative 4. So we're going to plug them in and see if it makes the sentence true. That is the sentence 8x minus 8y is less than or equal to 8. So x minus 8y less than or equal to 8. So we plug in 2 for x, and we're going to minus 8 times, and we'll put the negative 4 in parentheses so we don't lose the minus sign, is less than or equal to 8. So we got 2 plus 4 times 8 is 32, is less than or equal to 8. Okay, so that's 34. Is 34 less than or equal to 8? I do a less than or equal to with a question mark above it. No. So it looks like 1 is the answer. But let's go on and check the rest of these. They won't take long to do. 0, 0. So we go 0 minus 8 times 0. Is that less than or equal to 8? Is 0 less than or equal to 8? Yes. So this is a solution. So B is all right. And what about C? Negative 3, 2. Okay, so we put in negative 3 for x, minus 8 times 2, and then we have less than or equal to 8. So it's negative 3 minus 16 less than or equal to 8. Well, we have negative 19 is less than or equal to 8. So that's true. That's a yes. And let's do the last one. D, 9 comma 9. And so is 9 minus 9 times 8 less than or equal to 8. That's 9 minus 72 is less than or equal to 8. Is that true? Yes, it is. Because it would be, what, 63? Negative 63 is less than or equal to 8. So the answer to that is number 1. Number 2, tell whether the ordered pair 5. Oh, let's graph this, by the way, since you wanted to know about graphing. Let's graph it. Okay, now we know that the graph of an inequality in 2 variables, so graph of inequality in 2 variables has 3 parts. There'll be 2 regions and the boundary line, which is the graph itself, if you will. Okay. Now, the boundary line is either part of the solution, or it's part of the region that is part of the solution, or it's part of the region that isn't. So one of the regions includes all the solutions, and one of the regions does not. And the solution region will include solution region, includes the boundary line, the line, if the sentence conjunction, that is less than or equal to or greater than or equal to. If the sentence, by sentence I mean the inequality statement, 8 minus xy less than or equal to 8, we call that a sentence. be less than equal to, greater than equal to, less than, greater than, equals, not equal to. All of those we call conjunctions. If the sentence is greater than or less than, then the solution region does not include the boundary line. And the boundary line is broken. And here, let me put in parenthetically, if the solution region does include the line, the boundary line is solid. Okay, so what can we determine right here in this situation? Okay, the line is solid. It's less than or equal to. Okay. Now, what form are we in? It's x minus 8y is less than or equal to 8. Well, this is standard form. Now, we could do a couple different things. We could put this into slope-intercept form. Now, to graph the line, graph as if the sentence is an equation. Now we know it's going to be solid, so we don't have to worry about making a dash on it. So in other words, we're going to graph 8x minus 8y equals 8. We're going to graph that. And we're not going to worry about... Now you can do all this in your head. I'm just writing this out so you can see what I'm doing here. Now when it's in standard form, when you're in standard form, the easiest thing to do is simply calculate the intercepts. Actually, this is always pretty easy to do. Okay, so if x is 0, then you've got minus 8y equals 8, y equals negative 1. So if x is 0, y is negative 1. Now, if y is 0, so you put in 0 for y, negative 8 times 0, then you get x equals 8. So now you got 2 points. This is really easy to graph. So you got 0 and negative 1. Sorry about this, line isn't very straight here. So x is 0, y is negative 1. And then y is 0 and x is 8. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. And that's it. Okay, and we're going to make a solid line. And so what's the slope? The slope is 1 over 8. Positive 1 over 8. So we can do another one of these. 1, 2, 3, 4, 5, 6, 7, 8. So I'm making another point over here. And that's about as far as we could. So 2, 3, 6, 7, 8, 9, 10. Okay, so I'm going to draw my solid line. I should use a ruler. I don't have a ruler handy for myself right now. Okay. So I got my solid line drawn. So there's the boundary line. That's going to be the boundary line between the two regions. Now, how do I determine where the solutions are? So we have one region that's going to be nothing but solutions, and the other region is no solutions. We know the boundary line includes the solutions because that's what an inequality does. See, the solution region is a set of all pairs of numbers that are going to make this true. So there's, anyway, so let's plug in the typical test, if the line does not include 0, 0, is to plug in 0, 0 and see if it makes the sentence true. So I got x minus 8y is less than or equal to 8. Now we're going to plug in 0, 0 and see if it makes the sentence true. If it's true, it's part of the solution region. And then if it's part of the solution region, then that's where we're going to shade. So we'll do 0 minus 8 times 0 is less than or equal to 8. Is 0 less than or equal to 8? Yes. So 0, 0 is part of the solution region. And so we shade the side, we shade the region, the side of the line that includes our test point, 0, 0. Now remember, you can only use 0, 0 if the line doesn't go through it. Okay? All right. So that's that. So we answered the multiple choice question, but we also had practice doing the graph, and we'll do that with the rest of these problems. All right, so let's go on to number 2 here. Is the ordered pair a solution of 9x minus 9y is less than 19? Well, we just plug it in, okay? So we got 9x minus 9y is less than 19. Notice this is less than, okay? So when we graph this, the line, the boundary line, will not be part of the solution, so the boundary line will be broken. So we have 9 times 5 minus 9. Now we're going to put in a negative 1 in parentheses because this minus 9 is part of the original sentence. Okay, so we have 9 times 5, which is 45. Let me just write 45 minus 9 times negative 1. So that's plus 9. Negative times a negative is less than 19. So is 54 less than 19? Is it? No. Okay, so the answer to this is B. It's not a solution. Okay, so now let's graph it, though. Even though it doesn't ask us to graph it, let's graph it. Okay, so here's our graph. Okay, now again, we are in standard form. Okay, so we got 9x minus 9y. So let's let's do this down here. Let's plug in 0 for x. Okay, so we'll make a little table. Now x and y. When we put in 0 for x, we get minus 9y is now remember, we're going to do this, we'll do this as if it were equal. We're going to make these points as if they're equals. Okay. Makes it simple. We don't worry about, because all we want to do is find out what the points are. Okay, so 9x minus 9y equals 19. So put in 0 for x, minus 9y equals 19. So y equals 19 over negative 9, negative 19 over 9. Okay, we put in 0 for y, we're going to get 9x equals 19, so x equals 19 over 9. Now 19 over 9 is just about equal to 2. Okay, now in terms of the graphing, that's, graphing's pretty inexact anyway, so we're not going to worry about, it'll be about 2. So when x is 0, y is around negative 2. And when x is around 2, y is 0. Okay, now we know that the line is broken, so we're going to make a broken line like this. Notice the slope is 1, positive 1. Okay, now we got our boundary line made. The question is, which side do we shade? Which side has the solutions to it? Okay, well here's good old 0, 0. So we plug in 0, 0, and we see if 0, 0 is a solution. So 0, 9 times x is 9 times 0 is 0, minus 9 times 0 minus 0. Is that less than 19? Okay, so now we're using the inequality. So we got 9x. We only used the equals just to calculate these 2 points. So now we're going to go back to this. So is 0 less than 19? It is. It is less than 19. So we shade the region that includes 0, 0. But notice that the boundary line is not part of the solution region. All right. Moving on. Let's go to the next problem, number 3. Okay, tell whether the ordered pair. Okay, number 3. So we got negative x plus 6y is less than 10. It's less than, so when we graph this, the boundary line will be broken, not solid, and the boundary line will not be part of the solution. Okay, we're going to plug in negative 8 and negative 2 and see if that's a solution for this thing. So first we're going to answer the question. So we're going to have negative, open parenthesis, negative 8, because we don't want to lose any of our signs, plus 6 times negative 2 less than 10. We're going to put a question mark here. That's the question because we're asking this question. Okay, so we're going to have 8, negative negative is positive 8, 6 times negative 2, negative 12, less than 10. So is 8 minus 12 less than 10? Well, 8 minus 12 is negative 4. Is negative 4 less than 10? Yes, it is. So negative 8 comma negative 2 is a solution. Okay, now let's graph it. We'll draw our graph. Okay. And we will make our points by turning the sentence into an equation, just for the sake of making 2 points. And since all of these are in standard form, then we will we'll just calculate the intercepts. So we put in 0 for x, we get 6y equals 10. So when x is 0, y is 10 over 6, which is 5/3, which is 1 2/3. Okay, not that hard to graph, about 1 1/2. Okay, now when y is 0, put in 0 for y, we get negative x equals 10, so x equals negative 10. So when y is 0, x is negative 10. Okay, so y is 0, x is negative 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's down here. Okay, so we got to go down a little bit further. I can adjust this graph. Let me adjust this thing a little bit. I can do it over again. So I got more negative here. Okay, so I'll put it up a little bit further like this. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So that's negative. No, I did it the wrong way. All right, sorry. That's x is negative 10, y is 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here we go. Okay. There's negative 10, 0. And when x is 0, y is about 1 2/3. Okay, so 1 about here. Okay, and the line's broken. Like this. All right. And the slope is 1 over 6. Now, 0, 0, which is right here, here's 0, 0, is not on the line, so we can use 0, 0 to see if the sentence is true. So we have negative x plus 6y is less than 10. So we put in 0, 0. 0, negative 0 plus 6 times 0. Is that less than 10? Yes. So 0, 0 is in the solution region, and so we shade this one. Now, let's talk about something else in problem 3. We got the equation. So far, we've been dealing with these equations in standard form. We got negative x plus 6y is less than 10. But suppose it was in another form, like slope-intercept form. Okay, so let's put the equation. That'd be another way to graph it. So let's do that. Okay, so I'm going to put this in slope-intercept form as if it were an equation. So I got negative x plus 6y. So when you're figuring out either a pair of coordinates by finding the intercepts, like we've been doing, or when you want to put it in a different form, like slope-intercept, turn it into an equation. Turn the sentence into an equation and then do your work. Do this only for graphing the line, but always use the sentence in the inequality form when you're determining which side is the region with the solutions. So we're going to turn this into slope-intercept form as if it were an equation, just for the sake of graphing it. So first thing, we'll add x to both sides. So we got 6y equals x. Equals 10, 0. Okay, equals, so we add x to both sides, equals x plus 10. Then we're going to divide both sides by 6. Okay, so we got 6y divided by 6 equals, then we have x plus 10 divided by 6. So y equals x over 6 plus 10 over 6. So y equals, we call the slope 1 over 6, 1/6x plus, and then the y-intercept is going to be 5/3, 1 and 2/3. Okay, so we could graph this like this. Let's see, we could just use this here. So the y-intercept is 1 and 2/3 about. Okay, and then the slope is 1 over 6, so we would go up 1 and then over 6. So go up approximately 1. You're going to go up to 2 and 2/3, okay? But, you know, it's graphing, so it's rough. And then you're going to go over 6. 1, 2, 3, 4, 5, 6 right here. And it's a broken line, so now here's your dashed line going through here. Now let's look at our previous graph. It's exactly the same. Okay, no difference. Notice it goes through 1 and 2/3 approximately. Okay, so either method's all right. And then you would go ahead and turn it back into an inequality. Now, here's the thing. Which way is the arrow going? We started out with negative x plus 6y equals 10. Then you would go back to the original inequality to find out where your solution is. Okay? All right. Like you did with the 0, 0. Okay. Okay, problem 4. Now here we got something in slope-intercept form. So we got y is greater than 3x plus 9. Okay, now here are describe the solutions. The points in the half plane, or region, that contain the point 0, 0. Okay, so that contain including the dashed line. Now we know that the solutions are going to include the boundary line, or the dashed line. Okay, let's hold on a second. First of all, it's greater than or equal to, so the line is solid. Okay? All right. So the line is solid. Now let's go further. Okay, let's do the test. Okay, so we're gonna test it for 0, 0. So is 0 greater than or equal to 3 times 0 plus 9? Question mark. So is 0 greater than or equal to 9? No. Okay, so 0, 0 is not part of the solution region. Okay, now A refers to a dashed line. Okay, and it says that it includes 0 there. So A is out. Okay, the line isn't dashed, for one thing. The line is solid, and 0, 0 is not in the solution region. Okay. Now B says the points in the half plane that do not contain the point 0, 0. Well, we know that it does include 0, 0. Okay. So the points in the half plane that do not contain 0, 0. Okay, that's true, including the solid line. All right, that's true. So the points in the half plane that do not include, so the point 0, 0, and it includes the solid line. So that's true. Now let's look at C. So B is the answer. Let's look at C. The points in the half plane that do not contain the point 0, 0, including the dashed line. Well, the line is solid, so we know that C is wrong. D. The points in the half plane that contain the point 0. Okay, we know it doesn't contain 0, 0, so D is out. Okay. Now, since we're going through the exercise of graphing, let's graph this. Okay. So we got y is greater than or equal to 3x plus 9. We're in slope-intercept form. So let's slope the y-intercept is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now the slope is 3. So here, let me make some more room. Y is greater than or equal to 3x plus 9. Okay, let's do it. Let's make a really big graph. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now the slope is 3 over 1. Rise over 1. Up 3. 1, 2, 3, and over 1. Okay? Now, that's the next point in the line. You can also go 1, 2, 3, and over 1. There's another line. Okay? Another point that's on the line. The line is solid. So we can come down like this. Okay, now here's 0, 0. And 0 is 0 greater than 9? No. Is 0 greater than 3 times 0 plus 9? No. So we shade the region, the half plane, away from, on the other side of the boundary line, which is solid. And the boundary line is part of the solutions. Okay. Problem 5. All right. Now what we're going to do in 5, even though it's multiple choice, we're going to graph it, and then we'll pick the one that looks good. And we can see, you can see where the line is, but we're going to graph that line anyway. We're going to do it ourselves. And then we will pick out the solution. So it's y is greater than 2x minus 6. Okay, so we can just use the slope-intercept, so it's really easy graphing. 1, 2, 3, 4, 5, 6. That's the y-intercept. The slope is 2, up 2 and over 1, up 2 and over 1, up 2 and over 1, up 2 and over 1. Notice I do this from the y-intercept. Now the line is broken because it's greater than. Okay, it doesn't have the equal sign on there. Okay, so it goes this way and that. All right. Now, is 0 greater than 2 times 0 minus 6? So, is 0 greater than negative 6? Yes, it is. So 0, 0 is part of the solution region. So we shade that region. Now we're going to look for the graph that's got a broken line and that's shaded so that it includes 0, 0, and that would be B. Okay. Now, graph the inequality. X plus 6y is less than 0. And, okay, less than or equal to. Now we know that only the solutions with solid lines we're going to consider, and that would be A and B. C and D are out because they have broken lines. Okay? So the question is, do you shade above or below the line? Now let's answer that question first, and then we'll go ahead and graph it ourselves. Okay? So x plus 6y is less than or equal to 0. Now, so do we include... Oh, now here's the... Let's see. Here's the problem. 0, 0 is on the line. Okay? Do you see this? Now let's put this in, you can see this if we put this in slope-intercept form. 6y is less than or equal to negative x plus 0. The y-intercept equals 0. So you can't use 0, 0 to test. Okay? Well, what's another really easy point to test with? Well, 0, 0 is on the line, but let's look at a point that's definitely not on the line. And that would be 1, 1, right here. See, 1, 1, not on the line, 1, 1. Okay, so let's try 1, 1. It's not on the line. Is 1 plus, so we're going to test with 1, comma 1. 1, comma 1 works just as good as 0, 0. So 1 plus 6 times 1, is that less than or equal to 0? So that's 1 plus 6 less than or equal to 0. Is 7 less than or equal to 0? No. So 1, 1 is not in the solution region. Now we said that the answers had to be A or B because it's less than or equal to. Okay? So 1, 1 is not in the solution region, so it must be shaded below the line. So the answer has to be B. Okay? Now, let's graph this ourselves, just, because for the sake of the exercise. So let's put this, we went through the trouble of putting in slope-intercept form already. So we have 6y is less than or equal to negative x. So y is less than or equal to negative 1/6 x. So how's that graph going to look? It's going to look like this. Here. So, well, the y-intercept is 0, 0, okay? So we go down 1 and over 6. 1, 2, 3, 4, 5, 6. Down 1 and over 6. 1, 2, 3, 4, 5, 6. And then we can go this way. 1, 2, 3, 4, 5, 6 to the left and up 1. And this is, so we have a nice, this is a negative slope, solid line. And we said 1, 1 is not part of the solution, and it clearly isn't, so we shade below the line. And this looks just like the picture in the problem, more or less. It's not as neat. Okay, here's another one. What number is this? This is number 7. Okay, now, it's greater than or equal to. Graph the inequality. Okay, so which one is the right graph? Okay, well, A and C have broken lines, so it can't be them because it's greater than or equal to, so it's got to be a solid line. We got solid line with B and D, so it's one of these two. So the question is, one of them shades up, one of them shades down. Otherwise, the graph of the line is the same. So x plus 4y is greater than or equal to negative 2. So can we use 0, 0? Yes. You can see 0, 0 is not on the line. So we can use that for our test. So is 0 plus 4 times 0 greater than or equal to negative 2? So, question. Is 0 greater than or equal to negative 2? Yes. So, 0, 0 is in the region of the solution, which you can see right here. Okay. So the answer is B. Now, let's graph it, and let's we can graph it either way. So let's do it x plus 4y. So let's do 0, 0. Let's do the intercept since we're in standard form. If x is 0, then y is going to equal negative 2 over 4, negative 1/2. Okay, and if y is 0, x will equal negative 2. So we can graph x is 0, y is negative 1/2. And when y is 0, x is negative 2. Okay, and this looks pretty much like the graph, and it's a solid line, like that. Okay, and we already determined that 0, 0 is part of the solution, and so it's shaded up, just like in B, with a solid line. Okay, now let's do it the other way. Let's convert it to slope-intercept form. So we got x plus 4y is greater than or equal to negative 2. 4y is greater than or equal to negative x minus 2. Y is greater than or equal to negative 1/4 x, dividing both by 2, minus 1/2. So the negative x is divided by 4, and the negative 2 is divided by 4. So we get y is greater than or equal to negative 1/4 x minus 1/2. And we make our graph here. So the y-intercept is negative 1/2, and the slope is negative 1 over 4. So we go down 1 to negative 1.5, then go over 4. 1, 2, 3, 4. And there's another line down 1 over 4. 1, 2, 3, 4. And so on. We go 4, 1, 2, 3, 4, and up 1.5, 1 up 1. So there's the line. Is 0 greater than or equal to negative 1/2? We put in 0 for x. Yes. We shade up to include 0, 0. Okay, and then problem 8. Okay, y is greater than or equal to negative 3. Okay, the green shaded region represents the possible solution. All right, so it's greater than or equal to negative 3. So it's solid. We got 2 broken, so it's got to be A or B. Okay? Now, greater than or equal to. So we plug in 0, 0, only there's no x, because the slope is flat line. The slope is 0. You can see this as y is greater than or equal to 0 times x, because the slope is 0, no change, minus 3. Okay, so we plug in 0, 0. Is 0 greater than or equal to negative 3? Yes. So 0, 0, 0 is part of the region, so the answer is B. So let's graph it. Y is greater than or equal to negative 3. This is pretty simple. Okay, we go to negative 3, and we draw a solid line. So we go 1, 2, 3, and then a solid line with a 0 slope, horizontal line. Okay, and 0 is included in the solution region, so we shade up to include 0, 0, and that's it. There's your graph. Okay, that is about